Alrighty, everyone. Thanks for joining us this afternoon. We have a fun and neat conversation to have. We were just having this conversation in the back of the room, and now we're going to bring it to the front. We're going to talk about mycotoxins. A lot of you have probably not really heard about mycotoxins, so we're going to kind of dig into what that is and how it's impacting our corn farmers, but also our grain millers and our livestock industry, and how researchers and agronomists are helping to work through mycotoxins. So Martha, I'm going to put you in the hot seat. Explain to us what mycotoxin is.
So mycotoxins are toxins that are produced by fungi that infect grain in the field. And when they infect the grain, they produce these toxic compounds to help with causing disease in the crop. So they contaminate the grain, and that can also occur post-harvest as well.
Are there 1, 2, 4? How many toxins are there?
Oh, there are many different types of chemical toxic compounds that fungi can make as they are growing on the crops. But in particular, there are big five, they say, that are typically aflatoxin, vomitoxin, fumonisin, ochratoxin, and zearalenone are the top big ones.
Here in the Midwest, more the Eastern Corn Belt, a lot of us have talked about vomitoxin. So talk with us a little bit about the difference between vomitoxin and aflatoxin. They sound the same, but I think they're different.
Yes. So those two key problematic ones that perhaps people have heard of are aflatoxin and vomitoxin. Aflatoxin and vomitoxin are both produced by fungi, but they're produced by different types of fungi. And they have different optimal temperatures and conditions that they favor to cause disease on corn and contaminate corn. In addition to being produced by different fungi, they also have different functions or different types of toxic effects. Aflatoxin is a toxin that affects the liver, and so it's toxic against the liver, and it is a carcinogen, so it causes cancer. Whereas vomitoxin is a inhibitor of protein synthesis, and protein is required for basic all metabolic functions in animals. So they have two separate types of toxicity that can occur. Aflatoxin is much more toxic to animals than vomitoxin. So it's 20 parts per billion that the FDA regulates for aflatoxin, and there is an action level. If it reaches that in human feed or food, they need to take an action to reduce that. Whereas for vomitoxin, it's 1 part per million. So the difference is kind of, if you think about it in a truck, 2 kernels of corn contaminated with aflatoxin would lead to an unsafe entire truck full of 1,000 bushels. Whereas for vomitoxin, you could have as much as 100 kernels of contaminated grain.
So as I think about that, I want to kind of go through the value chain here. Mark, I want to pick your brain. So what? Why is this important to growers? Like, how is this impacting our growers? What are you seeing as an agronomist? And then we're going to kind of go down the food chain here, and we're going to jump into our animals, and then we'll jump into our grain millers.
Well, I'll just start out and basically say that I've seen an increase in vomitoxin just in the last, like, say, 5 to 10 years. And as I was looking at some of the data, one of the things that really kind of stood out is that our humidity levels have been increasing. And you need to have, there's a researcher from Ohio State that did some studies with this, and he said you need to have an 80% average relative humidity. Well, in the last, I'm going to say 30 years, our average relative humidities have gone up about 7%. So our growers are starting to see this more consistently. And obviously, if they have this in their grain, they're getting docked for the grain. They have more FM in there. And because of that, they're actually seeing higher and more consistent rates of vomitoxin every year. So they're wanting to know how to reduce it.
So it's not just a toxin issue, it's an economic issue.
Absolutely.
How hard is it to get rid of that grain at times?
I would say sometimes it's very hard. I mean, they're trying to mix it with the good grain as much as they possibly can. But I mean, it takes a lot of time. And I mean, it's not very easy to get rid of it at all.
So, Adrian, talk with us a little bit about on the animal feed and what you guys are seeing at United Animal Health.
Yeah, so when we get high toxin loads, we really can't accept them into our feed manufacturing, into pellet manufacturing, because the animals are so susceptible to some of those toxins, and it really decreases their growth. We've done research that shows that 1 ppm of vomitoxin causes a 7% decrease in average daily gain. Those pigs will just back off feed. They don't like the taste of it. They don't want to be anywhere around it. And so once they back off the feed, they're just going to start losing weight. Then that's going to damage the gut. And once you get that gut damage, you're going to have opportunistic pathogens come in. So it's really a cycle of issues that are going to come along when mycotoxins are present within the diets. So it's something that we're very, very cognizant of. And while there's mitigation strategies out there, there's so much different toxins that we're going to be in the grain that not one strategy is going to get all the toxins that are in the diets.
Again, I hear a theme of economic impact. Again, growers, livestock industry. Eric, are you going to continue the same theme?
Can I just say yes? Is that a simple enough answer? Yeah, there's, for us, grain millers, we have a dry corn milling facility just northeast of here in Marion, Indiana. So we're making things like grits, snack meals, corn meals. Everything that we produce is destined for the food market. The stuff that you're going to find on your store shelves or go into your favorite corn snack products. So when we're looking at mycotoxins, it's really about human health and about the end user and about all of us as individuals and the snack products or corn products that we're eating. So we take mycotoxins pretty serious because of that. Martha was talking about some of the thresholds that, are out there for aflatoxin. Vomitoxin is pretty similar in that space. And it can vary depending on the types of products that, that corn is destined for. But for example, there's companies out there that are requiring, 200 part per billion or less on the vomitoxin, especially if that product goes into any kind of like infant or child snacks. So for us and the growers that we buy from, we have some pretty tight standards most days, to be able to hit those thresholds. So it's definitely an economic impact for the growers that we're working with that are trying to deliver corn to our facility and even, companies like ourselves and anyone along that value chain to meet those thresholds and deliver good, high quality, clean corn that we can process for human consumption.
Something that we got talking a little bit about back there was sampling. Martha, talk a little bit about the sampling between you, Eric, and Adrian. Can you talk a little bit about sampling and kind of what you guys are seeing?
So detection very much, they have these ELISA tests that they're testing for. But in order for those to be accurate, lots of people I hear, okay, they're not accurate because we go through once and it tests, it's positive, it's very high levels, then we drive the truck around and it comes back, we test again. It depends on which kernel is being tested and that sample size. It's impossible, if you think about it, it's one kernel in that entire truck. If you happen to sample and get that kernel, then it'll show you how much it is. So as you're passing along, so you start, the farmer brings it in, they do a sampling, they run a test, all of this at high value cost in order to get it done. And then if those kernels are missed, and then it goes to the next stage in processing, in milling, at every single stage, there's more tests occurring, more cost, more economic loss accumulating in that. So sampling is what is the problem in the testing, because you can't take the entire load, grind it up, and test to see exactly how much it is. You have to take a small portion so you get an estimate of it.
Yeah, and we've taken multiple samples out of a single load just to run those different samples, about 8 samples out of a load. And if it's a low toxin sample to begin with, it typically will range about 1 difference in ppm of vomitoxin. It can be found in that one particular load. But if you have a high range of vomitoxin anyway, your sample load can go from, say, 5 ppm to about 15 ppm throughout that entire load. So making sure to have a very, grab here, grab there for sampling is going to get more of a realistic representation of what's going on within that load of grain.
I really don't have anything more to add beyond what you both have said already about this, but sampling isn't perfect. And we just, all of us in the supply chain, we're all doing the best we can to get good representative samples to understand what is there. But I made a little bit of a joke when we were standing in the back. The only way to really know is test every kernel, and that's unrealistic. So we do the best we can to get these good representative samples to understand, what's the risk of having these mycotoxins in a load of corn. But on aflatoxin, 2 kernels, you said.
Yeah.
It's really easy to miss 2 kernels when you're doing some sampling. So we're all doing the best we can to try and find what is there and understand what's present.
So is this something that like new innovation AI could possibly do? Like I think I heard a little bit of that possibly going on.
Yes, with the USDA Agricultural Research Service, but also, partnering with industry and with processors and so on. We're trying to develop new innovative technologies to make predictions based on weather conditions and strategies, mitigation strategies used in the field, so we can predict about how much is there, how many times need to be sampled, and new technologies also for looking imaging wise. Can you select out which kernels might be most impacted, most infected by this fungus? So those can be eliminated to reduce that overall amount of toxin. So yes, constantly advancements that we have with technologies and with AI searching through this. The more data we have, the more.
And Adrian, that's artificial intelligence, not the other AI. All right, so let's kind of flip our script here a little bit. I want to talk about the silver bullet because everybody thinks that there is one silver bullet. Mark, you and I have had the conversation. It's not just a silver bullet. It's a couple of different things. Martha, we've had this. So I'm just going to toss this to the group. Who wants to lead this? Is there truly a silver bullet fix to this, or do we have multiple modes of action that need to be worked on to help combat mycotoxins?
I guess I'll start with that and just say that, I know you guys talked a lot about sampling, and I'm trying to make it so that your samples are clean to begin with. So starting from the field, and we're trying different approaches to reduce the amount of vomitoxin, and I think that there's multiple different modes of action. There is no one silver bullet to this whole situation, but we can look at genetics, and we have actually found that there are certain genetics that really have more of a tendency to be a little bit more tolerant of the fungus. We actually know that there's some silks on some of the hybrids that basically are not as susceptible, and so it won't actually get into the ear. So, there's some silk susceptibility with this. Once it hits the cob, there's actually some cob susceptibility that goes with that. And other things that we're trying to do is we're trying to mess with like plant populations as well, because we know it goes in on the silk, and if we can get the whole ear pollinated, it doesn't have an entry point to get into the ear. So we're messing with populations. We're kind of trying to see if populations can actually push open the husk, because we know that if we have a more open husk, that the fungus will actually kind of dry out and not move down as much. And then we've also started looking at other aspects from a fungicide standpoint. There are some fungicides that are kind of registered, but we're actually looking at fungicide timings, because there are other fungicides that are looking at it that can actually increase the amount of vomitoxin. And then probably the last thing that we're also looking at from an agronomic perspective is looking at sulfur rates. So we've actually we had a good conversation in the back about this where we just started, but we're having some of our producers use like say 45 to 50 pounds of sulfur. And I have not found an exception to this yet, but those people that are using those high rates of sulfur are having much less vomitoxin levels. So we're seeing a lot of like really interesting things in trying to tackle it initially from an agronomic perspective, so you don't have as much in the samples.
Yep. Just to follow up there on Mark's approach, genetics, enhancing the genetics is one. Unlike some other pathogens, there's not a gene for gene. So that silver bullet is going to be a challenge to develop a fully, complete resistance. So it's going to require this approach of having the correct genetics with management strategies, along with the guidelines of how you can help maintain that to reduce the amount of pathogen in the field, reduce its virulence, enhance the susceptibility of the plant, and overall so it can be resilient also to the different types of stresses in the environment, which tends to make that overcome the resistance strategies that we have.
What about grain handling? Eric, are you guys doing anything on the grain handling side?
We've been looking at a few different things. We've been running into things like mycotoxin off and on for years, kind of like everybody else in the animal industry or in the milling industry. So yeah, it is definitely things that we're looking at. Is there better cleaning technology that we can use, better color sorters, lights, or whatever it might be, just to be able to try and reduce infected kernels or remove infected or damaged kernels that we can then help use that to pull down the level that's in final product or whatever it is. And even any type of cleaning solution that we can figure out, and I don't mean that like wet cleaning solution, but cleaning for grain cleaning that we can figure out to produce a cleaner sample that growers can use or we can use on the milling side is always something we're looking at. But also looking at some of the same things that Mark was talking about and Martha of how do we address the disease triangle and kick out one of the three legs here to keep these fungal diseases and mycotoxins from forming.
So let's think about what other initiatives that we need to be doing or that we are currently doing. And I want to hit on like partnerships, collaborations. So talk with me a little bit about what does that look like today? What do we need to be doing more of? What do you wish we're doing? Where is that at today? With the industry, with research, what's that look like?
I can take a first crack at this. I think we all probably have our own opinions and some pretty similar comments, but the industry as a whole, we've kind of really been, speeding up and taking up some more collaborative approaches to this over the last couple of years. For us as a milling company, we only have so much control within what we can and can't do to try and address these issues. But, Mark was talking about some really good items over here of, how do we work collaboratively across, genetics providers, input providers, a process and cleaning, whatever it might be, to address this from many different angles, because fungicides, sulfur applications, these can all be part of it that the grower can work on to address mycotoxins and fungal diseases. We can work on it. So partnerships are really critical because we got to attack this from multiple different angles if we really want to have long-term success. Otherwise, we're going to solve the issue for a year and have it back next year and not really have good long-term solutions.
Martha, talk with me a little bit about the coalition that got started a while back.
So it's evident that all of us within the different sources, within the government, within universities, within industry, with the animal side, the milling side, the producers, each of us have been doing our own research and putting forth effort to solve this problem. But the really exciting thing that has taken place with the national corn growers, partnered with industry, with Beck's, with the millers as well, is they're bringing together this national mycotoxin coalition that is partnering all of these efforts, university, industry, so that we can gather the data that we have individually been put it together now for a unified effort to actually eliminate this problem instead of just dampening it. But can we actually come up with real translatable solutions to solve this?
Thinking of that solution focused, Adrian, what are you guys seeing in the livestock world? Any solutions there or research analysis?
So United is kind of weird. If you do have high toxin corn, we'll buy it from you. Don't worry. We actually run research trials. We've got our own farms, and the only way we can understand what the toxin is doing to the animal is to actually test the animal and see what mitigants that we can utilize within the animal to make sure that the toxin is not going to cause a lot of problems or a lot of growth issues. So that's kind of what we're doing on our side. United has run well over 100 mycotoxin trials on different species, trying to make sure that our animals are staying healthy as possible, because we know that toxins are not going to go away. We always say there's no such thing as clean corn. So how can we make sure that we're either diluting the toxin out or it's not causing a problem, or what new technologies and feed ingredients are available so we can keep the animal healthy and make sure it's growing to the best of its ability?
If I'm understanding right, we've been fighting aflatoxin, vomitoxin for a while. So why is that? Like, why has nobody figured out that silver bullet, those 5 things? Like, is it because it is so complex, or is something changing? Like, why have we not been able to figure out how to combat this yet?
Well, Martha mentioned 5. Those are the 5 classes. I think we have well over 300 masked mycotoxins that are that we can analyze for and look at, and do they cause problems? Do they not? I mean, they're metabolites, so they're always going to change. So it's hard to just say, yeah, we've figured out vomitoxin, but that fungi is going to be like, okay, well, you figured that one out, so I'm going to produce a different toxin instead. It's just like your body. When something, you think you're doing great, everything's going well, you fixed your arm and now your shoulder hurts, right? So so finding the big common cure, I think, is going to be very difficult.
And the fungi are very diverse. So there are many different types, but even within the same species, you have some of them that are adapting to different environments and our agronomic practices so that they can overcome that. They want to consume the corn too, so that they're constantly changing and utilizing, different approaches. So as we're changing, they're also at a much faster rate because they have such a faster life cycle.
And I think it's important to understand as well that, the same fungus that causes like vomitoxin in corn is the same fungus that causes head scab in wheat. And so that fungus is around for like several crops. So, I mean, it's able to propagate pretty well. And I talked about the humidity levels, but I want to go more specifically on this. When I looked at it just in Ohio, from 1990 to 1999, our average relative humidity was 73%. From 2000 to 2009, it jumped up to 77%. And then from 2010 to 2020, it actually jumped up to 81%. So that's almost an 8% increase in Ohio. And I think we're starting to see it become more of an issue outside of Ohio, where it used to only be a Great Lakes issue, but now it's becoming a much wider issue because I think our relative humidities over the Midwest, which I think a lot of us have encountered this past year, that's part of the reason why.
So it's not just an Ohio or Indiana thing. We could also have an Iowa issue, a Kansas issue, is what I'm hearing. I want to touch a little bit. So we've talked domestic impacts. Internationally, this has a major international impact when we think about trade and what our growers work through with that. Who wants to tackle that conversation and the impacts there? Oh, come on now.
So the limits that we have within the U.S. for advisory limits and regulatory limits, action level limits, are actually a little higher than they are in Europe, for example. So in order to be able to sell to Europe, they have to be even more stringent, even lower concentrations and ppms. So they have to be the cleanest and the best quality grain so it's impacting trade dramatically. And
alrighty, so call to action. Each one of you, what's that one thing that you want to call your livestock growers, your grain millers, your growers, your researchers, whoever it may be? What's that one call to action to help us with this that you have today?
I guess we're starting with producers. I mean, my call to action is I will say I am heavily focused on looking at the product side of things. So I am sending we have a lot of plots, and I send all of our in one section of Ohio, I will send the plot results to Coopers to get them to analyze and sample to see which products are actually better for against the vomitoxin. And I would actually say that observations out in the field very, very closely match what we're seeing when we send the results in. So I am very heavily focused on looking at like a lot of the genetics and seeing like how we can get the genetic resistance, and then working with cooperators to even reduce it further by their agronomic practices.
For me, it's being on the research side. This is a very exciting time to see everybody getting together, and collaboration, I think, is key, and putting our data into the same formats so that it can be used by these latest technologies and like AI to analyze it and give us back the feedback that we need to solve these problems.
I would agree with the research aspect of it as well as the sampling. And then if you're a livestock producer, it's not always a toxin issue. The vets will always tell you it's mycotoxins. That's not always it. Don't always blame mycotoxins, but they can be a contributing factor. So the more we understand about them and we can understand how it's growing and how it's impacting that way, the better I think the livestock production will be.
So I guess my call to action, we've hit on a lot of these, but it's really a lot of short-term thinking, but also the long-term thinking that has to go along with it. What can we do in the short term is, a lot of the things that Mark was talking about is what are we doing in the field? What fungicides can we be using to control the pathogens? Are there genetics on the market right now that we can help use to reduce the presence? Us looking at cleaning aspects, those are really the short-term goals or the short-term call to actions that we have. But, there's a lot of these other long-term things that I think are really critical if we're going to try and stem this issue long-term. These collaborative research efforts, what genetics can we put on the market in the long term from companies like Beck's? What new, control products can we use, whether it's fungicides or biologicals or anything else that we can use to help reduce, even fungal infections to reduce the risk of mycotoxin formation. So there's a lot of research to go into this on a long-term basis, which are, we say long-term, but we're realistically talking maybe 5 and 10 year efforts to try and make, meaningful changes in that aspect. But there's a lot of short-term things that we need to be focusing on as well.
Anything else from the group? All righty. Well, thank you guys. Thanks for joining us, everyone. We will see you next time.